So I think this is working. And I'm exploring trying to stream videos going forward. As I mentioned in a newsletter that I posted a couple weeks ago, I have really enjoyed making these videos, but at the same time, I find that the editing just kills me and sucks up so much time. Also, in the editing, you don't get to see the full Pat experience. You don't get to see all of my goofs. You see some of them, but not all of them. And so I thought this might be a bit more organic, natural experience for you all to experience, seeing how I go about recreating different visuals, problem solving, things like that. Also, I would really welcome people's comments as I go through here, questions that you can throw in the chat, and I'll try to respond to those as I go along. One of the things that you have probably already noticed is I'm not super familiar with this software. And so it might take me a little bit to get adjusted to this new software because it's going to be a new way of doing things for me. So if you have comments along the way, go easy on the production quality. But again, if you have questions about how I'm doing R or going about recreating these visuals, let me know. If you have suggestions in the future for what might make these better, by all means, let me know. My hope is to maybe be on here for about 2 hours every Wednesday morning, starting at 9 Eastern. You'll see I'm a little bit late because I had some technical problems, which is, I think, par for the course in getting going with these types of things. So again, I hope these will be a relaxed, somewhat informal approach to the videos I've already been making. All right, let me figure some things out here. Looks like there are a few people watching, so thank you. Yeah, so let's get going. My fear is that I'm going to go through all this and that you will, I'll go through all this, I'll get to the end and realize that nothing was actually posted to YouTube. But hey, I'll figure it out eventually. So what I would like to do today is to share with you a visual that I talked about in a previous newsletter. Again, if you want to get access to my newsletters, go down below in the description if you're watching this in the future. Alternatively, if you go to riffamonas.org, you will find there a link to register for my newsletter. It comes out about once a week, where I talk about data visualizations and at a kind of a 30,000 foot view, how I would go about recreating those visuals. And so this is a website called Our World in Data that has a lot of great data stories, as well as access to data and different types of visualizations. For whatever reason in the US, fertility rates have been a big thing. I don't know if this is because of Trump or because of Musk or whatever, but the birth rate in the United States has become a thing. Certainly it is now below replacement level, I think, and certainly if we remove immigration, then it will certainly be far below replacement, and that has people concerned, I think, rightly. So this was an interesting article that I saw that talked about the baby boom. The baby boom is a period that started right at the end of World War II, from about 1946 to 1964. This article has a number of different ways of looking at the baby boom and kind of the echoes, both in the United States as well as across the world. And so if you keep scrolling down through here, at the very bottom, there is this infographic. And so this infographic I thought was really cool. It is a ridgeline plot. Let me see if I can get you a bigger version of that. I already downloaded a bigger version that I'll just put right here in the middle. And so this ridgeline plot for each year indicates the fertility rate for a specific age. So the x-axis is the woman's age. The y-axis is the year that that woman was born in, right? So again, going from like 1918 to 1970. So the bottom line would be for a woman born in 1970, when she was, say, 20 years old, which would be this tick here by my crosshairs, you would then see that, you know, this coloring or this height of this histogram would indicate the fertility rate. And so they mentioned over here in the lower right corner that a value of 0.25 means that 1 in 4 women at that age in that cohort gave birth that year, right? So clearly there's not many women, thankfully, having babies at 12, and there's not many women at age 50 having babies either, right? And so what they hope to show with this infographic is that you kind of have this ridge going over the top of the ridgeline showing Showing the heightened fertility rate, right? And so I thought this was really compelling and interesting for a number of reasons. One of which was because it is a infographic and sound is low. Okay, let me turn that up a bit. Thank you. Let's see if that's doing any better. Does that help, Ian or Renzi? Let's see. All right. Okay, so let's go with this for a little while and we'll see how things go. Thanks for letting me know that the sound was low. Again, it's an infographic, right? So this is the type of thing that you might see made into a poster or put on a website. And it's got annotation in the right side. It's got the data on the left side. It's got title, a subtitle, all sorts of different annotations. If you go back to the original article here, they say that the scripts to recreate this plot can be found on GitHub. And so if you go to Saloni Datani's GitHub account through Our World in Data, you'll see the various scripts, or really one script, that she used to create these visuals, okay? One of the things I noticed when I was exploring this earlier was that if you look at these visuals, they don't look like infographics, right? Great, the sound is better, wonderful, thank you. And so like this dark mode one is I think what they put into the infographic, right? And so my sense of what they did was that they used R to make this visual, and then they probably took it and put it into something like Illustrator to get us something that looks like this, right? What I would like to do is basically recreate this visual, but I want it to have all of the other stuff. I want to recreate this visual, right? I don't want to recreate this visual. I want to recreate this one. And so depending on how far we get, we'll see where we go in doing this, okay? Along the way, of course, please ask questions, and we'll see how we go. And I'll try to explain my thinking kind of like I do in most of my other videos, albeit, much less polished probably than the final edited version. So what we need to do is get the data. So the data is available through the Human Fertility Database. And let's see, I have that opened up already. So this is humanfertility.org. And if you come to humanfertility.org, it'll look like this. I don't know a whole lot about the people behind this website, but my understanding is that they collect a lot of fertility data from around the world. I'm going to be doing this using data from the United States because that's what the original was, and I'm in the United States. If you're in Japan, I would encourage you to try this with the data from Japan or from Belarus or Switzerland or Taiwan or wherever, right? I think that's one of the nice things about a site like this is that you can take what I'm doing for the US and apply it to whatever you're doing. And if you're following along with this, I would love to see what the same type of plot looks like for a different country. So again, I'm going to click on USA. And we now have this page. It's got a variety of different sections: period summary indicators, cohort summary indicators, other synthetic indicators, age-specific data, birth counts, fertility tables, all this stuff. So I'm not a demographer, as you've probably figured out. I'm a microbiologist. And so I don't totally know what all this stuff is about. And so the challenge is to find the data that we want that we can then read into R. And so I know that we're interested in the cohorts, right? And so if we look at, let's see. This might take some troubleshooting, but we'll see. So birth counts, population exposures, and rates. So if we look at birth counts, we have year and cohort. And so we want the age-specific fertility rate, right? because that is what was in that lower right corner in that legend. And so this would then be the year and the cohort by age for the fertility rate. So I'm going to try this. So let's go ahead and click on that link. You do need a login. I don't know why they force you to have an account. I think it's most likely so that they can justify to their funders that people are finding this useful. And so I already have an account that I will go ahead and plop in here, log in. It's a very simple process to generate that account. And of course, in the process, it lost track of where I was. And so now we have to do that all again. So again, it was age-specific fertility rates, year, cohort. I think that's what I want. Okay. And so this is what the data looks like, okay? And so we have the year, age reached during the year, the birth cohort, and the fertility rate. I don't think that's actually what I want. So let's try that again. Let's try year, age, cohort. So this is year, age, cohort. And then the age-specific fertility rate. So I'm pretty sure this is what I want. One way that I can cheat is I can come back to the notebook, and you're not supposed to post the data because that was part of the terms of getting the account through the human fertility database. So let's look at what she did. And I'm going to look for the dark mode version. Okay, and so that's right here. And so this is her code. I'm not really interested in following her code. I want to do it myself to see if I can generate it from scratch. And so I'm looking for this cohort DF. And let's see. So they have US cohort age specific fertility rate. Okay, and so that, if we come back here, age specific fertility rate. So this one, right? So it has the cohort, the age, and the age-specific fertility rate. All right, so let's try this back here again. Again, that was cohort age ASFR, and here we have cohort age ASFR. We have the year here, which I don't know that we need or want. But it looks like the year is supplied regardless. Let me just check this age-specific fertility rate here. That's the cohort age-specific fertility rate. So this is the one we want. So again, that was this age-specific fertility rate, all births combined, birth counts, population exposures, rates, cohort, and there we go. So I'm going to go ahead and copy this link, and I'm going to then save this page to my directory, which I already have a directory here, 2025-06-11, which is today as I'm recording this. And this is a text file. It's not a tab separated or a comma separated values file. So that's a little bit funny. So we'll go ahead and save that. And I'm going to go ahead and copy the link. And here I am in our studio. I'm going to go ahead then and paste in the link here to remind myself of where I got the data. But if I come over to files, I see I have that US ASFR VH, okay? And so what we can do then is read, and so then the question is, well, how are we going to read this? Well, before I read it, let's go ahead and load these libraries. So I'm going to get the tidyverse. I'm going to get show text. Show text will allow us to bring in fonts from Google Fonts. And so the serif, let's see, where'd that go? The serif font, like the title here, is the Playfair font. And then the sans serif font, like we have for the lowercase font here, or the smaller, bluer font, is a Lato font. And so I'm loading all those here. And I'll get all that stuff loaded up. And so now what we want to do is read a read function. And I'm not totally sure what it is. I think it's like read table. And so read table is designed. Let's see, where'd that go? Read table, I think is what we want. So let's go ahead and try read table, and we can try something else if it doesn't work, right? So we'll do USA ASFR vh.txt, running that. I think that worked, kind of, right? And so let me open this up so you can see what's happening. It then is reading in this file, and if I click on the text file here in RStudio, it'll pop open the text file, right? And so what it's doing is it's using this first line for column headings, right? So United States, cohort, fertility rates, and so forth are each column headings for separate columns. And so then what you see down here is that it's reading those in, and it's reading them in as different types of columns. But you get warning messages of parsing failures. And then like under fertility rates by cohort, those columns, you get a bunch of NA values because that wasn't right. So what we actually want to do is skip the first two lines. And so we can do that here in read table by doing skip equals 2. And that already looks a lot better because now we have cohort age ASFR, and we're off to the races. One other, I guess two other things that I'm noticing about this is that my cohort is coming in as a double. So that's that DBL, so it's a numeric. My age is coming in as a character. I want that to be a double. And my ASFR is also coming in as a character. And so let's do the ASFR first. And so what I'm noticing is that we have a period here for many, many rows in the ASFR column. And I'm fairly confident that that period indicates an NA value. And so within read table, we can specify the character to use for an NA. So we do NA equals and then period. We now see that all of those periods have been turned into NA values, right? And the type of data is a double, okay? So cool, right? That solved that problem. And again, that will be useful because what we're going to want to do is map the age-specific fertility rate to the fill color within the ridgeline, right? And so if there's a character, that just would work really, really weird, right? And then our age now is of type character. And I see that that is because we have like 12 minus, which is like 12 and under. And actually, I'm pretty sure that if we pipe this to print n equals 100 to get the first 100 lines, that there's also down here 55 plus, right? And so I think if we remove the hyphen or the plus, and then we can convert the age column, where are we? Right here, into a numeric, okay? So let's go ahead and try that now. So I'm gonna go ahead and remove that print, and I'll do a mutate on age, and we'll use the stringer package, and I'll do str replace, gotta spell it right. And so str replace is going to want the column. So we're gonna look at the age column, right? And then the pattern is going to be, I'm gonna use a square brace minus plus with another square brace. And so what that square bracket means is match either character in the age column, right? And then we're going to replace that with nothing, okay? So now when we run that, we've gotten rid of that hyphen, and I'm confident that we also got rid of the plus. I guess I could always just go ahead and do print n equals 60, and let's see, that 55 no longer has the plus. Cool, right? So what we can do is go ahead now, and we want to convert this age column from a character into a double, okay? And so we can then go ahead and pipe the string replace function output into as.double and run that, and we now get age as a double. As I'm doing this, one thing I should share is that I still use the old magritter pipe of % greater than % rather than the newer base R pipe, which is the vertical line like this and greater than sign. I'm still not sold on the base R pipe. So you might see both pipes as you're looking at R code out there in the wild. Let me know if you're using the base R pipe or not. I think the base R pipe is supposed to have a little bit of performance improvements over the magritter pipe. It's only 2 characters. The other thing you'll notice is that I have yet to memorize or adopt the keystrokes for the pipe. Someday I'll work on that. All right, so now we have the cohort age and the ASFR. One thing I would like to do is to go and now change my column headings to be all lowercase. So I see a question, is there a difference between 12 minus and 12 in the data? So there isn't a 12, it's only 12 minus, right? So the 12 minus is 12 and under, and the 55 plus is 55 and over. So like for 1978, if we go ahead, we can check this, right? So we could do like filter, cohort, and let's just pick a random year of, let's say, 1950, and I need 2 equal signs, that we see that there's only 12 only shows up once, right? And so I would agree, if it was 12 minus and there was a 12, then we would probably want that 12 minus to be turned into like an 11 or something like that. But I think we're good here. Okay, so like I said, we want to go ahead and turn those column headings to be all lowercase. I like column headings, variable names, file names to be all lowercase because then I don't have to think about what the capitalization is. I also don't have to hold the shift key as I type things. So we can do all that in one step by doing rename underscore all, and then we can do to lower. And so that then applies the to lower function to all of our column headings. Okay. So if we kind of look back at our plot here, one thing that we want to start thinking about is what data do we actually want, right? So we have cohort data going back to 1878. And maybe that's interesting, right? But the plot that I'm trying to recreate goes back to 1918, right? To the 1918 cohort, comes forward to the 1970 cohort, right? So if I take this, let's see how far it comes into the future. We can then do tail and see it comes to 2010, right? And so I will want to go ahead and filter the data to do cohort greater than or equal to, what did I say, 1918, and cohort less than or equal to 1970. And so now we see that our 1918 data, our data starts at 1918 and comes back to 1970 if I go ahead and tail that, and that also comes up to 1970. So I see a question, is I'm always using janitor clean names. Is there a reason not to? No, if you like janitor, go for it. There's this trade-off, I feel, between using special functions in packages versus more generic functions in other packages or in base R, right? And so I could learn clean names, but I also already know rename all, right? And to lower. And so I think if you looked kind of at the code within Janitor, you'd probably see that like rename or clean names is doing the same thing that I'm doing here, right? So I personally don't see a benefit to learning Janitor at this point. I should dig in and learn more about Janitor because I'm sure there are things that will make things easier. But for me, this type of step is easy enough. I know rename all, I know to lower, those types of things. And they're more generally applicable to a variety of problems than clean names from Janitor is. Now on the other side, we're about to learn about some functions from ggridges, which will make ridgeline plots. I have no idea how to make a ridgeline plot in ggplot2 without using the ggridges package, right? I'm positive there's a way. I just don't know it. And it's going to take me far longer to figure out how to do it than it would take me to actually use the ridgeline functions from ggridges, right? So it's a bit of a trade-off there. If you're using it, you like it, awesome, go for it. All right, so we now have this data frame that, again, goes from 1918 to 1970, has our age, and has our ASFR data, right? So now I think what we want to do is go ahead and plot the data. And so to do this, we're going to use library ggridgeline. or ggridges. And it's not auto-populating, which makes me think I don't have it installed. And so I'll come over to Packages, install ggridges, and install that. And so now that should be installed. Okay. And we're going to want to go ahead and start ggplot, AES. So on our x-axis, we're going to put the age. The y-axis will be our cohort. Our fill is going to be ASFR. Okay. And then what we're going to want to do is geom ridgeline gradient. Okay. So there's geom, as you kind of saw from the pop-up here, there's geom ridgeline and geom ridgeline gradient. The gradient will allow us to have a gradient of fill colors across the histogram, right? Like you can kind of see that the color changes across this histogram, right? Where like here in the middle, it's a light blue. And then as you kind of go off to the right and left, you can see that the colors get darker, indicating lower fertility rates, right? You can almost see the striations, right, for the different ages of women in this data set, okay? Cool. So let's go ahead and run this and see what it looks like. And it is angry. Let's see, where did I get the error message? Problem while setting it up. So the height needs to be set as an aesthetic. So we'll go ahead and do height equals ASFR. That works. No error messages. GG save. And so let me see. Okay, so this is the output in RStudio, which is pretty hard to see. And what I like to do is to output things directly to the file so that we can get our plot in the same aspect ratio as what we want the final version to be. There's kind of ways to do that in the plots window within RStudio, but ultimately I find this is far preferred. So what that means is though that I need to go and open up my Finder and get this going. And this is the fertility ridgeline. And what we see is bonkers. We get a bunch of vertical lines. Actually, I think it's kind of oscillating. And what this reminds me of is when I do plots with like geom_line to make line plots, that geom_lines has a group aesthetic, right? That allows me to tell geom_line what data goes together to make a line. And I'm thinking I need to do something similar here to show geom ridgeline gradient, what data go together, okay? And so what we can do is come back up here and do group equals cohort, okay? Much better, believe it or not, right? And so now what we see, let me zoom in on this a bit more, is that you can kind of see the histogram there, right? But we're going to have to do some adjustments to make everything look just right. But this is the start of our ridgeline plot. Cool, huh? All right. So let's go ahead and look at the help for geom ridgeline gradient down here. And again, these work geom ridgeline gradient, geom density ridges, right? And so I'm trying to look at some arguments for the height, right? To change the height. And I don't see anything. Let's see. I thought that there was a height or a scale. So I see scale equals 3 here in that example, but I don't see scale up here. So I think what I'm going to do is go ahead and try a scale, because I think scale will allow me to change the height of the ridgeline, right? So if I do like scale equals, I've got to spell it right, scale equals, let's say 5. And so that then makes the ridge lines a bit taller, right? And so I think that's kind of along the lines of what we want to do. Theirs are actually much larger. So something that we could also do would be to scale the data within the year so that our height is a value of 1, right? And so if I kind of come back here and remove this scale equals 5, then, okay. So now, basically the height between the ridge lines is 1, right? But I've got really low ASFR values, right? So like the highest value is 0.25, and so that's only going up to a quarter, right, of the height between the different ridges. So what I will do then is I'm going to go ahead and scale the height. And so I'll come in here and do a mutate. I'll do scale ASFR, and it's going to be ASFR divided by the max of ASFR. But I want to do that for each year, I'm pretty sure. Okay. Actually, no, I don't want to do it for each year. I want to do it over all the years, because what that will do is that like the highest peak will be really high relative to kind of down here, like in 1970, where it's much more muted, right? And so let's go ahead and scale it across all years, all years and all ages, right? And so then my height can be scale ASFR. And so then let's go ahead and put this on a separate line so it doesn't go off the right side. And that is unhappy. Oh, why are you unhappy? So the only thing I added was this. So let's run this and make sure that works. So I'm getting NA values, right? And that is because I have NA values here in ASFR. And let's see, if we come in here to max, I can do like na.rm equals true, which will go ahead and remove those NA values. Alternatively, something else we could do would be to drop NA. So let's do drop NA on ASFR, and this will remove like 19, 18, 12, 13, 14, right? And so we see that those get dropped. And so now when we run this, it works without any error messages. And so now we see that like our highest ridge line goes up basically to the previous ridge line, right? Actually, I'm noticing that the years here are flipped on the y-axis. And Rents asks, shouldn't you use stat identity scale equals 1 or something like that? And in my sense, I guess you could do that. I think like the stat function ultimately is a convenience function. So again, this is kind of like using janitor versus rename all. This is working, and it gives me kind of the appearance and behavior that I'm expecting. So I'm going to roll with this. So now if I go ahead and add in here like scale equals 5, I now get my ridge lines to overlap with each other and kind of look like what they had in the original, right? Of course, theirs is in opposite order, right? So 1918 is at the top, whereas for me, I have 1918 at the bottom, okay? So let's see. Let's go ahead and do that first. Let's go ahead and flip the order of our years. And we can do that. So whenever we want to change the order of things, that's often either going to be done with a factor or with the scale function. Let's try the scale function first. So we'll do scale y continuous. And our limits, let's go from, at the bottom, we'll do 1970, and at the top, we'll do 1918. So I think if we invert the limits, I think it should flip everything for us. Oh, it's still unhappy. So what did I do wrong? Let's see. So let's run this stuff to see if this works. So whenever I get an error message like this, I kind of go back to where I was before I try to figure out where the problem is. So the problem then is on this line. And I think it's because you all are watching that I'm screwing this up. So we look here, breaks, limits, and I think it's unhappy because I flipped the order. And so I think what we could do would be here to do like a transform, right? So let's go ahead and do transform equals reverse. All right, good. So now we have 1970 at the bottom and we have 1918 at the top, right? Great. Now we're gaining on it, right? I, though, want to be able to modify the padding at the bottom and top of the plot, right? So there's an expand argument that's being added to the data that I want to get rid of. So we can do that within scale y continuous. Ultimately, I'm going to do it within chord Cartesian, and we'll do expand equals false. While I'm here, I'm also going to do clip equals off. This will allow me to plot data outside of the plotting window, which I'm going to have to do to get all this text in, okay? So let's try this. And so now we see that that really uses the full size of the plotting window, okay? Great. So that's adjusting the y-axis. Now let's think about the x-axis, right? So they have 20, 30, 40, but I don't know where they're starting or where they're ending, right? So like, I think right about here is probably 12. So I had to guess they're going to 10 and maybe they're going up to like 50, but I don't know. So let's do some math. We've got R here. So I'm gonna go ahead and use preview to look at trying to estimate what these values are at the left side and right side of the plot. And so like this rectangle I just created is 272 pixels wide about, right? And it represents 10 years of age, right? So if I do 272 divided by 10, then that's like 27.2 pixels per year, okay? So now let's go to the left. And again, dragging that to the left, that is 283 pixels, right? So, so let's see, it's going to be 283 divided by 27.2 is 10.4 years, right? And so basically, this is 10, right? I'm just going to call it that that's 10 because this started at 20 and then we subtracted 10.4. That gets us to 10. And so what we could do then in here in scale y continuous would be like limits. Let's do 10.4. Let's just do 10, right? 10, and then we'll want the upper limit as well, right? And so now what we can do is the same type of thing on the right side where I'm making this rectangle and I need to figure out where the grid lines on the x-axis are. So I think like right about there, right? So that's 214. All right. Okay, so 214. So 214 divided by 27.2 gets us 7.87. So I'll call that 8. And so again, that's going to be added on top of 40. So let's make that 48. Okay. And again, it's unhappy. Oh, right. Because I put limits within scale y continuous rather than scale x continuous. All right. And so we'll do limits equals that. And I copied and pasted too much. And I forgot a plus sign up here. Get that. Great. And so now what we see is that the data, the x-axis again starts at 10 and goes out to 48-ish, right? Yeah, we're on our way. Cool. All right. So now we have to make some choices about what to do next. I think what we will do is, what? Let's go ahead. Oh, what should we do? Let's go ahead and work on the background because I think that's going to take some work. So one of my favorite tools on a Mac, you've probably seen before, is the digital color meter. So we go Applications, Utilities, Digital Color Meter. And so this handy dandy tool, I am sure if you're on Windows, there's a Windows tool that does the same thing. I know there's also tools within Chrome or any browser really that will allow you to do the same type of thing. And so basically, I can put my cursor over a spot on the screen and get that font. And so I think, let's see, what do I want? So to be totally honest with you all, I've recorded this video about 3 or 4 times now, and I finally got it to work. But then my laptop got stolen. And so I'm working with a new laptop. And so I don't have all my old settings. And so that's another reason why I haven't been making these videos and why I felt the need to kind of change the format, because it just gets a little too hard. Anyway, so I don't think this is doing things the way I want. So if we come up to color, copy color as text, no, that's not what I want. Let's see. Well, let's just try this. Okay. So we'll go ahead and copy and then come into RStudio. If I plop that in, that's giving me RGB values rather than the hex code, right? And so I want the hex code because that's easiest to work with. So let's see, generic RGB. Okay, that's RGB. Oh, let's see. I want to get the hex code. Display values as hexadecimal. Oh, there we go. View, display values as hexadecimal. Wonderful. Okay, now we've got that. So we'll go ahead and copy this, and then, good, that gets us our hex code. And so I'm going to then take this into theme, and we'll do plot.background equals element rect fill equals that hex code, right? And I can go ahead and get rid of that. And then my color, I also want to be the same thing. Cool. And so now what we see is that the background is actually a lot darker than theirs. And so I think, let me see here. If I come back to this, come back to our digital color meter, and let's do Adobe RGB. Does that change anything? Maybe. All right. I think that color is closer. It's a more blue than what I had before. Okay, so, but our panel is still this gray with the white grid lines. And so to change the panel, I'm going to remove the color, the fill color of the panel. So we can do panel.background element blank. Okay. And so now you can see that we've gotten rid of that gray background, right? And so Renzi is saying on Windows, I use Share X. Cool, thank you. So now we have matched the background, but our grid lines are a bit different from what they have, right? And so let's go ahead and I'm going to zoom in on this and try to match their colors for the lines. And let's see if we can get close here. Okay, got that. And then, all right, so coming back to RStudio, we can then do panel.grid element line color equals that. And so now we have grid lines that more or less match the color that they have, right? So our lines are a bit thicker than theirs. Also, they've got minor grid line, or I've got minor grid lines, right? So like I'm going every 10 years with major grid lines and every 5 years with minor grid lines, whereas they go every 5 years. So let's go ahead and get rid of the minor grid lines. And so we'll do panel grid dot major, and then we'll do panel dot grid dot minor equals element blank. And so then those minor grid lines get taken off, but I want things every 5 years, right? So we can come back up to scale y continuous and do breaks equals, and I'm going to use the seek function, and we'll go from say 1900 to 1970 by 5s. So I don't have data back to 1900, but who cares? It's not going to matter. It's only going to show the stuff that's within the limits of the data. So now what we get is our data every 5 years, although I guess I lied because we have 1915, so maybe I should do 1920. Okay, I guess we do care. Okay, so now we got rid of that 1920. Cool. I'm noticing that our grid lines are a bit thicker than theirs, right? Theirs are pretty thin, mine seem kind of thick. So again, here in panel grid major, that's an element line, so we can do then line width equals, let's do 0.2. And so that makes it quite a bit thinner. And I think if we kind of put those on top of each other, that looks pretty good. Okay. Now, one thing is that I am losing the horizontal grid lines to my grid line, right? So my grid line plot is sitting on top of the line. And also we then have this black line as kind of the cap of the ridge. And so I think we're going to want to do a couple things. So first, what I want to do is change the color of that line to match my background. And I also want to make it thinner, right? So let's go ahead and grab the background color here. And then we'll come up to geom ridgeline gradient, do color equals that, right? And then we can do line width equals 0.5. So I don't know if that did anything for my line width, but the line certainly blends in. Let me see if we do 0.2. Yeah, that worked. That made it more thin. And maybe we can take it up to say 0.3 and call that good. Okay, so now we've got our line for the top of the ridge line. It basically dissolves into the background, but like whereas with like 1935 here, you can see the blue grid line all the way across. Here we're losing it with 1935, right? And all the other years. So an idea that I have would be to add a little bit to each cohort value so that the ridge line isn't sitting right on that grid line, but that it's moved up, again, just a notch. So let's try that. So we can come back up here to cohort in our y-axis, and let's do like say plus 0. Let's start with 0.1. And I think I moved it in the wrong direction. If you zoom in here, you'll see my ridgeline now is below the line, right? And I think that is because, of course, I flipped the order of my axes. So instead of plus 0.1, I want to actually do minus 0.1. And there we go. Now we have our ridge line. Now we have a grid line below each of the ridge lines, right? And so if I zoom in, there is a bit of a gap there, right? So let's maybe, instead of 0.1, let's make that say 0.05. And if we zoom in again, that looks pretty good, right? We might want to tweak that later, but I think that's going to be pretty good. Cool, all right? So we're making progress, I think, right? Now, one thing I'm noticing is that for their plot, they have the tick marks as the same color for the grid lines, right? So let's go ahead and change those tick marks to match the grid lines, okay? And actually, as I look at this on the left side, I'm kind of seeing a bit of a shadow from the ridge cap going down into the grid line. So maybe I will make this say 0.7 and we'll mess with the stuff later once we've gotten all the sizes and placement and proportions right, okay? Cool. So now what we will do is the tick marks. So we'll do axis.ticks equals element line, and we'll do color equals the color of our grid lines, right? So we'll go ahead and grab this color and plop that in. And so now we see we have our tick marks, right? But our tick marks are thicker than our grid lines. So let's go ahead also and grab this line width 0.2. And so now those tick marks are more thin, okay? Cool. All right, hopefully you can see this is taking shape. I now want to go ahead and, what do I want to do? Let's go ahead and play with our axis labels, right? So I think something initially we can do is to remove the X and Y axis titles. Maybe, you know, I'll end up putting in the labels later. I think probably using like an annotation with geom text, but let's go ahead and remove those just to get things cleaned up a bit. And of course we can do that with labs. I'll do X equals null, Y equals null. While I'm in here, let's go ahead and put in the title. So I'll go ahead and copy that. And we'll make this title. And this our world and data is inserted from kind of the watermark, which I'm not going to worry about. And so this needs to be in quotes. And then the subtitle is here. And we then have a caption, which is down here. There's also a caption in the lower right corner. I'm not going to worry about that quite right now, but we'll see. So go ahead and plop that in. And I'll go ahead and put in some line breaks here as they had it. So, and I probably forgot a plus sign at the end of all this. And there we go. We have our title. We got rid of our X and Y axis titles. We'll worry about formatting the titles here in a bit. Let's see. Hey, so Rento Saljo says, completely unrelated, I was able to get accepted by CRAN today for a NHL data scraper. Awesome. That's really cool. I assume NHL is hockey, National Hockey League. Well done. That's really awesome. I know it's a great feeling to get your package accepted to CRAN. In some ways, that's almost as hard as getting a paper accepted. So well done. Congrats. And unfortunately now what I found is the hard part is maintaining it, right? So, but celebrate those victories. That's pretty awesome. Well done. So I'm glad I was able to help in any way. Great. So let's now go ahead and change the color of our years as well as the size. And so again, I'm going to zoom in here and use my digital color meter to get the colors, because it's a different color than the grid line. So I'll go ahead and get that. And in here then we'll do axis.text equals element text. And we'll do color equals that. And there we go. We now have matched their color, I think, pretty well. So we're using a different font than they're using though. And so we want to change the font, and we'll also want to shrink it, right? So to get that font, that's the Lato font, we'll do family equals Lato. And let's also do size equals 8. And so that's the right font. It still seems a little bit too big. If I put like these numbers next to each other, let's go ahead and take it down to say 7. And I think that's pretty good. Maybe it's like 7.5. I'm going to leave it there. And so now our y-axis text matches theirs. Cool, huh? All right, now for the x-axis. And so something that's odd about the x-axis text is that it's actually at the top, not at the bottom, right? And so we need to flip that. And so we can come in here and do scale x continuous. And I forget the argument. Position, right? So left or right, let me move my face so you can see what I'm doing here. Where'd that go? Position. For the position scales, the position of the axis, left or right for the axes, for the y-axis, top or bottom for the x. All right. So in here, we'll do position equals top. And so now you'll see that we no longer have the ticks or the numbers on the bottom. Instead, we have them up at the top. Very cool. However, of course, we do want ticks on the bottom because they have ticks on the bottom. We've also lost the 1970 from the bottom. And I suspect that that is because, again, we're moving our ridgeline to be above the line. And so because we turned off the expand, we've lost the 1970. So because that is annoying me, let's go ahead and add in the 1970 data in the tick. And to do that, I'm going to change the limits on my scale y continuous. Limits, and we'll do 1918 to 19, let's try 71 and see what that looks like. Seem to be running into this problem a lot today. What did I do? Limits 1918 to 1971. So here I think I probably have to reverse it 1971 to 1918 because I reversed it with the transform equals reverse. No? Okay, let's turn off our scale y continuous. Okay, that worked. And oh, if I had to guess, it's not happy about my 1980. Oh, I put 1981, 1918. All right, still not happy. I'm going to make this NA and have it pick, yep, the limit there, right? And so by putting in the NA, I'm allowing the ggplot system to pick the outer limit, the upper limit for the y-axis, okay? So that's cool. These ticks at the bottom are going to be too long. I should hold off on adjusting things too much, but let's go ahead and put this as 1970.5. And so now we have tick marks at the bottom. We also have the grid line at the bottom, and we're in good shape. One thing I noticed is that they go 20, 30, 40. I'm starting at 10. So let's go ahead into scale X continuous. And in here then we'll do breaks equals 20, 30, 40. That got rid of the 10. It got rid of the 10 label, right? So this is going to take a little bit of work. So let's go ahead and put the 10 back in. And there it is. Okay. So I don't want the 10. So one thing we could do on this then would be labels. So we could do 20, or I could do nothing, 20, 30, 40. And so that drops the 10, right? But it still has this like line going up, right? Whereas they don't have the line going up from 1920. This is basically like a really long tick mark, right? So I think what I'm going to do, instead of having a break at 10, is I'm going to draw a segment at 10, okay? So let's go ahead and try that. I feel like I'm maybe getting things a little bit out of order here, but because I get distracted by things that annoy me in the plot. So let's go ahead and remove that. And so that removed that line. And so now what I can do is come back up here. And I think what I'll do is, like I said, I'll do annotate, and we'll do geom equals segment. And then we need to give it x and x end and y end. So x is going to be what I had, which was 10, right? And then y is going to start at 1970.5, and y end is going to end where? 1920. 1920. And then let's do color equals the same as the grid line color, which is this, right? And I'll go ahead and also grab that line width of 0.2. And where'd we go? Okay, right here. Okay, and so let's put this color stuff on the next line. Get a plus sign there. Cool. So now we have that line, basically kind of like the axis line for 10, but we don't have the line going from like 1920 up, matching what they have, okay? Hey, Leonel, thanks for coming. All right, so something else I'm noticing is that they have a bit of a space between the x-axis text and that grid line. And so we can get that with a margin. And so if we do axis text dot x, we can do element text and margin equals margin. And on the bottom, let's go ahead and put like 5. And that didn't do anything. And I think that's because I need to have x.top. There we go. And so now we got a bit of space between the text and that grid line. Okay. Cool. All right. So this is coming along, right? Let's see what to do next. Let's go ahead and format our titles, since I put these in here and they look kind of nasty at this point. I'm going to go ahead and modify this. Yeah, so I think the first thing we'll do is the title and the subtitle. They are left justified on the panel rather than on the plot. And so to get that over, we can go ahead and do plot.title.position equals plot, right? And then we can do plot.title equals element text. And we will then do family equals Playfair. And so that's really hard to see. So let's go ahead and try to match the color here. And we'll get this in here, get this goldish color. And let's see, that was plot title. We can do color equals that. And we also want face equals bold. Bam, nice, right? And so that's looking good. But I think our font is a little bit small. If I put, well, those H's actually here and here are about the same size. So that's pretty good. I feel like the T's are a little bit small. Oh, whatever. It's probably okay. They have a bit of a margin at the top. So let's go ahead into plot title and we'll do margin equals margin. Actually, you know what? I'm not going to do that here. I'm going to do that in plot.margin. Margin. And then the T is, I'm going to put at, say, 5. R I'll put at 5, the bottom at 5, and the left at 5. And we'll be adjusting these as we go through. All right, so that needs to be increased a bit on the top. So let's go ahead and make that 15. That comes down maybe a little bit too far. So let's make this, say, 13. And I think that's pretty good. I'm happy with that. The line on theirs ends after the of, right? So let's come back up here. And we can put a line break in there with that \n. And so I can see the font, our font is a little bit more compact than theirs. I'm not going to worry about it. I think there's just subtle differences in the fonts we're using. I'm using the free version from Google Fonts. They might have a more proprietary version or be doing something slightly different. One thing I still notice about the title is that theirs has more space between the two lines. And so we can adjust that with line height. Let's do like 1.2. And so that opens it up a bit. I think that's pretty good. Maybe we'll go to 1.1. And I think that's great. Okay, cool. So the next thing we want to do is the subtitle, right? And so the subtitle is the Lato font, and I think it's the same color as our text on our axis, right? And so that was this color and Lato. So let's go ahead and grab that. Also grab the size while I'm here. And then here we can do plot.subtitle equals element text. And I'll plop that stuff in there with a comma. Maybe I'll put this on a separate line. Cool. So we've got that in now. Let's go ahead and put a line break between of and births. Right there. Okay. And our font should probably be a little bit bigger than it currently is. And so let's see, plot.subtitle, I have 7.5. Let's take that up to say 8.5. I feel like that now is a bit too big because it runs off the side of the screen. And so instead of 8.5, maybe we'll just make it 8. And I transitioned back and forth between the two screens here too quickly. And so it's kind of truncating things, but I think the title and subtitle here are looking really good. I'm happy with that. One thing I'll go ahead and do to the subtitle is to add a margin to the bottom to add spacing so that we can go ahead and put in the women's age axis title, okay? So let's see, that would have been in plot subtitle. And here we can then do margin equals margin. On the bottom, let's put it at 20. All right, so just kind of comparing mine to theirs. I think that may have been too much space I added. And so instead of 20, let's make that say 18. That brings that up. And I think that looks pretty good. Yeah, cool. All right. So the top of the plot is looking good. Happy with that. Now let's look at the annotation in the bottom left. So by default, everything gets right justified in the caption on the panel rather than on the plot, right? So we'll come back up here and we'll then do plot.caption position equals plot. And then we'll want to do plot.caption equals element text. And we'll want to do hjust equals 0 to make it left justified, left justified, sorry. And I think that's the, well, nope, that's a slightly different blue. All right, let's get the color for that blue. Kind of scroll down to the bottom here. grab that. And then that will be plot caption. Color equals that. Family equals lotto. All right, cool. So we've got it left justified. It's too big, however. And also, I'm noticing that like data source and our world and data.org are bolded, whereas the rest of the text here is not bolded. So I've already loaded ggtext. So for plot.caption, I'm going to use element markdown, right? And let's wrap that. And let's see, around data source, I'm going to put 2 stars to make it bolded. And then around our world in data.org, I'll make that bold with 2 stars. And then this \n won't work because it needs the HTML tag for a line break, which is BR. And so now we can see that we've got bolded there, but we need a line break after against, and we're going to need to shrink the font, right? So let's go ahead and get that line break in here after against. All right. And then down here again in element markdown, we're going to want to do size equals, let's see if we can compare the size of things, right? Like, so this does seem smaller than the numbers on the axis, and that was 7.5. Let's go ahead and make this 6. I think that's probably pretty close to the right size. I'm noticing that the 2024 goes out to about like 27, whereas mine is at about 25. So maybe I could up it just a smidge to say 6.5. And I think that's good. Of course, we need some line height increase to match what they have, right? So back up here, we can then do line height. Let's do 1.1. And I'm going to move this up, the size up, so I'm not using up so much space. All right. So that doesn't seem to have done much. So let's go ahead and plot caption. Let's maybe take it up to say 1.2. That gets us more space. I feel like my font color is a little bit more muted than theirs, but I'm not going to worry. And maybe we need some more space at the bottom to kind of bring up the caption. So that was in plot margin. So the bottom, let's go ahead and make that 8. That brings that up. I think that's pretty good. We now need some space between the caption and the bottom of the plot. And so we'll do that also in the caption like we did for the subtitle, right? So we'll then do margin equals margin, T equals 10. And I think that's pretty close. Maybe we'll take it up to say 13. And I think that's pretty good. Maybe we could take it down to say 12. All right. You've probably learned that I like to kind of futz with things a bit. So, okay, that's good. And so now I'm looking at these lines, and I'm noticing that like this like 1930 grid line on the right is a little bit lower than the one on the left, which means I need to add more space. And so maybe I can start with adding more margin to the bottom of my axis text. Right here, right? So maybe if I make that 8, that brings that down, but that's a lot of space. So maybe I'll make this 7 instead. That's still a lot. So let's make it 6. Okay, that's good. But I think what I want to do is maybe increase the height of my ridgeline, right? Like I'm noticing like this 1970 ridgeline is taller than mine. So let's try that and see if that kind of adjusts the vertical dimension of all this. And so we modified that up here with scale equals 5. Let's take that up to 7. And so, wow, that's like perfect, right? So if I take, say, let's come back up to like 1935. And again, I'm grabbing the crosshairs on the 1935 line and dragging straight across. And it's basically right on, right? And maybe it's a little bit higher on the right than it is on the left. If I take that and drag it over, that's pretty close. I think it's pretty good. I'm going to leave it right there and think I did a pretty good job. All right. Now let's go ahead and what should we do? I think it's time that we worry about the right side of the plot, right? Again, if you have questions along the way, or if you want to see me do something in the order you want me to do it, let me know, right? I haven't changed the fill color yet. I can do that, but again, I'm just kind of like picking things off one at a time. I think what I'll do is I'll go ahead and fix that right margin so all my margins look good or match, and then I'll go ahead and change that fill color, okay? So holler if you want to see me do something or if you want to see me try something. So let's go ahead and put the legend in the bottom right. Right, so mine currently is in the middle right, but let's see if we can move it down. And so let's go ahead and do legend dot position or justification right, and then we'll do bottom. Okay, so that moved that down. And so now what we're going to want to do is add space to the right of all this to move it over, right? So that there's more space for all this extra text, right? So again, we've set this up with plot margin. So on the right, if I make that like 20, that's then put more space to the right of my margin and moved everything over a bit, right? And so if I kind of measure from 40 to the right side of the screen, it's like 687. We're here. It's like 538. So we can do some more. So let's see. I put, where'd you go? Right to 25 or to 20. Let's maybe up that to 30. So it's 572. Again, over here, I had like 690-ish, right? So let's go ahead and up it to say 40. And if we pull that over, 603, that seems wrong. Wonder what I'm measuring here. So that's 603, 689. I wonder if the pixels are different. All right. So instead of measuring it, I'm going to put things on top of each other and then get these grid lines to line up. All right. So I went too far with 40. So let's take it back to 30. And I think it needs to come over. That's pretty good. And the 20 maybe needs more space to the left to kind of push things over. And so again, I'm noticing they have a bit of a margin to the left and right of their numbers on the y-axis. So let's take care of that. So we'll go ahead and do axis.text.y element text, not color, margin L equals, let's do 15 and R equals 5. Get a comma. Okay, that was too far. Let's take that to 5. That brings that over maybe too far. So let's do left at 3. I'm going to roll with that. And does that do it for the 20? It's a little far to the left. Maybe we can add something to the right. So let's take that up to say 6. And where'd theirs go? Here. Okay. I'm probably going to call this good. So that lines up nicely. And then the 40s look like they should line up nicely too. Cool. All right. So again, this is theirs. This is mine. We have now that right-hand margin in good shape. I am noticing a little bit of shadow, kind of like right in here for like that 1940 line. I think what I'll do is go ahead and subtract from the Y. Let's go up to 0.75. Still there. Let's go up to 0.08. Still there. All right. 9. I think that, it's still there. Okay, let's go up to 0.95. I know this is like gripping YouTube viewing material, but indulge me for a minute here. Okay, I think that's good enough. All right, so we have the dimensions on our plot right. We've got the colors right, except for the color of the heat map, right? So I'm going to go ahead and try to match their color here. And so let's zoom in on the heat map legend. And we'll go ahead up here, copy that. And we're going to want to change the gradient using scale fill gradient. And the low is going to be something, and the high, shouldn't be in quotes, the high is going to be that, right? And so then if we come down here to the 0, we'll go ahead and grab that and plop that in. And let's back this out. And that's pretty good. I feel like mine is just darker than theirs. I wonder if that's a product of my color meter. Let me come up here a bit, grab that, and let's maybe adjust this a smidge. Yeah, it's not like dead on. It's pretty close. I feel like theirs is just a little bit brighter than mine is. Whatever. Actually, you know what? I could probably do my digital color meter right there. And let's see if that solves that. Not really. Whatever. I think it's close enough. And I'm gonna let that roll. Okay. Cool. So now we have largely matched the colors of the two different versions of the plot. Nice, right? Now what I'm going to do is start to work on the text elements, right? actually, first, before I start working on the text elements, let's work on the legend because I moved that down there. Let's go ahead and see if we can't get it to do a better job of matching what they have in theirs. So we'll do legend.text, and we'll do family. Family equals lotto. It's not happy. Oh, that's because I want to do element text, right? And so now we've got that. And we're going to want to change the color of the text to match basically the other text elements we have, right? So I'll go ahead and grab this. Maybe I'll, again, grab that whole line. I should have done that before, but whatever. And so we've got the color, but we've got the white background, of course. So let's go ahead and get rid of that background. And we'll do legend.background equals element blank. Basically, I'm removing the background of the legend. That clears that up, right? The title should be age-specific fertility rate. We could do that in scale fill gradient, or we can do it in labs. Let's go ahead and do it in labs. We'll do fill equals age-specific fertility rate. And that gets everything skewed over to the right, of course. And so this needs to be smaller. And I'm not totally sure what all it just did. So hopefully I didn't just totally muck up my margins, but we'll see. Okay, so let's go ahead and shrink that. And let's see, legend.title element text. And I'm going to grab all this stuff. And I think that's still too big, right? So I put 7.5. Let's put it down to, say, 6. Am I going to add the logo to the top? I wasn't planning on it, but if you all insist, we might. Yeah, we'll see how far we get. Let's see. I'll do my best. But thank you for asking, and thank you for pushing me. Let's see. So we've got the age-specific fertility rate title. I feel like those fonts are pretty close in size. And let's then, we want to make the legend more narrow, right? And so we can do legend.key dot width, and then like unit, let's do like 15 pt. I don't think that did anything. If we take it down to 5, does that change something? Oh, that worked. Okay, so let's up it to, say, 10. I think that's pretty close. We want to shrink the height, so we'll also do legend.key.height unit. And I'm not really, normally when I change the key width and height, I'm dealing with like a individual plotting symbol, not a gradient. So I'm not really sure what this is going to change, if it's going to be the overall height of the gradient or if it's going to be each slice. So let's go ahead and do 10 pt and we'll adjust from there. Hey, I don't know what it did, but it got it close. And I think that's actually very close to what it should be. Yeah, I actually think that's like really good. Let's go ahead and change the, I think there's a margin at the bottom of the legend. That's keeping it up a little bit. We'll do legend.margin. And we do margin, let's do zeros all the way around. Okay. So we want it up a little bit from down there. So again, it's like top, right, bottom, left. So let's maybe make that 5. Okay, that's too far. Let's take it to 3. Good, I think that's right about where we want it. And yeah, maybe the top edge could go up a little bit, and we could do that again with this key height. Let's take that up to 11. Okay, that's too far. Let's do 10.2. I think that's good. All right. I feel like what? I feel like the font is maybe a little bit too small compared to what they have. So again, legend text I put at 6. Let's make it like 6.5 and 6.5. So I think that's pretty good. There is a bit of spacing between the gradient legend and the numbers. I think we can, there must be a margin. So let's see, is it in the text? I don't know. So let's go ahead and do margin equals margin, and L, let's do 0. I like to pick extreme values to see if there's an effect and then go from there. Hey, that was awesome. All right, so it's not 0, but let's make it maybe 2. And we'll maybe up it to 3. Okay, good. Now, I honestly don't like their tick marks in here. I don't like the tick marks over here either. One thing you could do is make the tick mark go all the way across, but you can't have a tick mark on right or left side like they do. So I'm gonna just remove the tick marks, I think. So in here we can do legend dot ticks. Yeah. Tick marks shown along bars or axes. Tick length. So tick length would allow us to make them go all the way across. Ticks is element line. I'm going to go ahead and do legend ticks element blank. And so that gets rid of those. And I think that's cleaner. This frankly looks a little bit sloppy. I don't know. Agree or disagree? I don't know. But one thing I noticed when I started futzing with the legend, because before I had ASFR, now I have age-specific fertility rate, is that it moved everything over, right? So let's go ahead and readjust our margin. We're going to want to reduce the right-hand margin. So again, that was in plot.margin. Let's take that down to say 20. Okay, that's going over. Let's maybe try, let's try 15. Let's go up to 10. I think that's pretty good. Maybe too far to the right. Maybe just, I'll make that say 12. And I think that's good. All right, I'll leave it there. And yeah, okay. So now what we have left to do is the text, okay? And so I'm going to add the text using, I'm going to add the text using annotate, okay? And so let's start with the axis titles, and I'll come back up here, and I've got another annotate up here. So we'll do annotate geom equals text. And we're going to want an X position, a Y position, a label, and then the family that is the sans serif, right? So that's going to be Lado. The face, so it's going to be font face equals bold. And then the size is, I think, the same size as our X and Y axis text. So axis text 7.5. Maybe a little bit bigger. Let's do 8. Okay, so we need to get the labels and the X and Y position, right? So we'll do women's age. Let's start there, right? So then X is centered at 30. And then Y, this is where that clip equals off comes in handy, because this is going to get plotted outside of the panel, right? And so this here is 1918. This is probably 1915. I'm going to guess this is probably like 1912. So let's go ahead and put in 1912. And I've got a comma here instead of a plus. Okay. And that is huge, right? And so it's plotting it inside the plotting window, right? And so that is because I put all of my limits within the scale continuous functions, right? Instead of within chord Cartesian. So let me go ahead and move chord Cartesian up here. The ordering doesn't matter. It helps me in terms of kind of organization to put things together. So this is the Y lim. And then we're going to want the X lim to go up here. And let's get a line break there. Clean all this up. I'm wondering if this NA rather is going to cause problems. So let's see. It did. Okay. Let's take this up to, let's try 1915. Okay. So that put the limit to 1915. We want to go back further, right? So let's try, where did I do that? Oh, right. Okay. I'm getting tired. Let's try 1912. Okay, that's too far. So let's see, 1915. Oh, I'm getting confused, I think, in my head of the order of things. Okay. Okay, I think that is right. That looks good. The women's age needs to move up. And so there's a few things that are happening here. So I'm using size, and I need to use size.unit equals PT to get it to shrink down. And then this blue of the text is the same. Let's see, legend.text, it was that color. And it also needs to be bold, which I think I already did, right? Bold, right. And color equals that. Okay. Cool. So women's age, but again, that needs to move up. So let's see, we had Y equals 1912. Let's make it, say, 1909. Closer. Let's bring it down to maybe 1910. All right, let's split the difference. And we'll do 1909.5. Cool. All right. So this should then go easier. Women born in the year on the left side, right? So if we come back up here, we can then do this, and we'll put a line break after born. And then, let's see, this is going to be left justified, whereas this was center justified. So we're going to need to add an H just, right? So we'll do H just equals 0.5 and 0. So the 0.5 is for women's age to be centered. 0 is for women born in the year to be left justified, right? And let's see. I'm getting an unexpected thing. Oh, why? Oh, this needs to have a C. Okay. And so then we need X to be, so this is 10, this is 20. Let's maybe make it 6. Let's try that. Okay, so that has it off to the left. It needs to go further to the left. So let's maybe make it 4. Okay, that was too far. So let's maybe make it 5. I think that's pretty good, but of course that needs to come down now. And let's make it say 1913. And it can come down further. Let's do 1915. And I think that's pretty good. The line height is a little bit too spaced compared to what they have. So let's see. That was in Annotate. Here, we'll do line height equals 1.1. Maybe it could be down to 1.0. Oh. And I think I forgot the comma. And I think that's good. So now we've got our X and Y axis text, right? Cool. Let's see. Let me see. How long? Let's see. Cool. Let's go ahead then and add the text we have in the right-hand margin, right? So I'm going to do this in probably 3 annotate functions, right? Because Baby Boom is one font, and then we've got these 4 bits of text are another font, and then this is another font, but a smaller size, right? So let's start with that Baby Boom. And again, with Annotate, you know what? I'm going to do it all at the end here so you don't have to watch me scrolling back and forth and get nauseous. So we'll do Annotate geom equals text, and maybe at the end then I'll put it back up where I would normally put it, right? So X is going to be something, Y is going to be something, label is going to be Baby Boom, it's lowercase, and then family is going to be Playfair, and font face is going to be bold. Size is, I think, the same size as the title, right? So that's plot.title back up here, which I don't know what the size was. Let's do 12. We'll do size.unit equals pt. So we need to get an X position and a Y position, right? So the X, I believe right here was 48. So if we go over a smidge, that would be like 47. And to make things easier, I'm also going to do hJust equals 0, okay? So then the Y position, this is, the bottom is like 1919.5, right? Or maybe the top is 1917.5. So let's do 1917.5, and then vjust equals 1. Okay, so that can probably come down a bit and be bigger, and obviously a different color. So let's go ahead and grab that color. And we'll do that. And then I did 12. Let's maybe make it, say, 13. And it can maybe go up to 14. Okay, I think that's good. Yeah, cool. All right. So that's the strategy, right? And so now let's go ahead and get these bits of text, and we'll do another annotate. Geom equals text. X equals a vector of values. Y equals a vector of values. Label will be a vector of values, right? So let's see. Okay, that's one string. And then this is another string. So I'm wrapping them in quotes and putting commas at the end, right? And then these 45 and 50 are accidentally grabbed from the y-axis, right? So let's make sure we've got all our commas in there. Good. Those are our labels. Good. And let's see. I'm going to put this over here to the right. And that won't work. Okay. I need to go ahead and put line breaks in here, right? So like at children and lifetimes. So we'll do children. Actually, let me do text box simple. I don't know if I can do that. I think Geom text box simple comes from ggtext, and I think it will automatically wrap stuff for me, but we'll see. I might have to go back and put in line breaks manually. So the x-axis for the 3 of these paragraphs, that position is going to match the left side of baby boom. Well, maybe it's really just the first 2, and then the 3rd and 4th are going to be adjusted. So baby boom was at 47, right? So we'll do 47, 47, let's do 46 and 48. We can adjust, right? And then Y, the women here, I think starts at like 1921. The starts at, say, 1929. And then after, I'm going to say is like 1936. And then later starts at like 1949. So let's see. We'll also want to do HJust equals 0, VJust equals 1, and family equals lotto, size equals, let's do 8, size.unit equals PT, and then we also want color to match what we had here, right? So grab that, plop that in, and I misspelled annotate. Can't find text box simple. Switch text work. Hey, oh no, that's theirs. Nope, that did not work. What if we did text box? No. Yeah, so I think the annotate is only going to work with text. So I think that will be good. But we need to put in line breaks. I say I need to put in line breaks, right? So I'll kind of toggle back and forth here and get in those line breaks. All right. So now I see that the line heights are too wide. So let's go ahead and do line height equals 1. And that, I think, pulls it together pretty nicely, right? So I think everything should now be in shape for me to go through and put in the line breaks, right? So surge in \n, and then to the ages, right? And then after the age, comma, or comma, the age, \n. And then after narrowed, \n. After women, \n. After their, \n. All right. And then let's see, of women, \n. And then a cross A, \n. And there we go. And I think that's pretty good. Yeah, I mean, the placement isn't perfect, but I think it's pretty good. I'm going to roll with that. And yeah, I think that's pretty good. So cool. That's my strategy, right? Now let's try the legend down here, right? This a value of 0.25, right? And we copy that, and we'll then do annotate. Again, geom equals text, x equals something, y equals something, label equals that. And so we're going to need to get line breaks in here, \n. Let's see, where are you? Right there. 1 and 4, \n of all women at, \n. That age gave, \n. I'm thinking there must be a way to do annotate with geom text box, but to get the line wrapping to work, but I don't know it. So that'll be something I'll want to work on to see if I can improve upon later. So the size of that, well, actually, we need to get the X and the Y axis positions first, right? So the Y is like 1962. And again, right here is 48. And so I'm going to say that's like 56, maybe. And I'll go ahead and put in the size to be something, size unit equals PT. The size is going to be the same as the legend text, which was 6.5. Okay. So we'll do 6.5. And then family equals lotto. All right. So I don't have the color. And I think I forgot the HJust and VJust. Okay, yep. HJust equals 0 equals 0. VJust equals 1. And then color equals this, right? Plop that in here. Hey, Terrell, thanks for joining. Cool, so that's in there. The font can probably be a bit smaller, and the line height needs to shrink down, right? So I think I did 6.5. Let's make it 6. And then we'll do line height equals 1. And I think I wanted 6.5. And let's make the line height 1.1. No, let's do 0.5. Okay, that's good. I think I'm going to move it to the left just a smidge because that 4 is like right up against the edge. Whatever, it doesn't really matter. let's do 55.5. Cool. All right. So there we go. What do you think? I haven't done a great job of matching the color, and I don't know why. And something I'd like to try is, well, first let me move these annotates back up to where I would normally put them. So I'll cut that there. And then I'd like to put all the annotates together. So I'm going to put that back up here and not forget the plus sign. Let's run it to make sure it works, and it didn't work. So where did I forget? Cannot use plus with a single argument. So a plus there. This isn't good. All right, so what I'm going to do is I am going to start here and copy or highlight back, run it. That gives me an error. Okay, that's good to know. So I have the extra plus sign right there. Okay, see, I found it. So again, my strategy for debugging and dealing with these types of errors is to kind of go back to the code that I know works and then add in code that I had just added, right? And then when I recreate the error, then I can triangulate in on the problem. So it's that extra plus sign. Everything works now, and good. So everything's been reorganized. And yeah, I feel like my blue is just a little bit more gray than their blue. And I'm just gonna leave that for now and not worry about it so much. Like I said, I think we're pretty close to having pretty much exactly what they have, right? Okay, so it's 11:30. I've been going at this for about, I think, an hour and 45 minutes now. And I don't know. Let me see something here. Okay. Let's see. So, a couple things. So, one thing that I do not know how to do, or that is not simple to do, at least in R, are the lines, right? So these annotation lines. And so I hope you don't consider it to be too much of a cop-out to skip those. These would be things where I would perhaps, add using Illustrator or PowerPoint or something else, right? There's a function, is it geom curve, that allows you, that's like geom segment, but geom curve allows you to draw a curved line, right? And let me do one of these. I think where it gets challenging is with kind of these, like, I don't know if that's like a hyperbolic line. But let's do this one down here for the legend and see if we can get close, right? So I'll go ahead and do annotate geom equals curve. And so we're going to want a x and an x end, and a y and a y end, right? And so the x, let's see, I put that final text bit, right, at 55.5. And so it's going to end at, like, what did I say, 55.5? Oh. Where'd you go? All right, 55.5. So let's try 56. And the y end on that, I guess I could have looked at both of these at the same time. was 1962, right? And so, yeah, let's have it end at 1962. And then our y will be like the start, right? Will be 1961. And our x, let's do 55, right? So let's see what this does. And it's there, but it's black. All right, so let's go ahead then and do color equals this. And so you can see like there is a curve, right? So we want it to go to the right a little bit, and we want the curvature to be in the opposite direction. So let's make the x end 57. So that comes over to the right a smidge, but now we want to like flip the curvature. And so let's come back to the help. And so curvature is 0.5, angle 90. So I'm not sure what those are. So looking down here, curvature, a numeric value giving the amount of curvature, negative produce left-hand curves, positive right-hand curves, a zero, a straight line, okay? And so I think we want like, the default on curvature was 0.5. I think we want like negative 0.5, right? So let's come in here then and do curvature equals negative 0.5. Okay, so that's cool. Maybe it should go up just a smidge. There's another argument, angle. And I think the default was 90. What happens if we do like 120? So that kind of moves the curvature to the beginning rather than like the middle, right? I wonder if that's what it intends to do. So let's try 30. Not bad. Let's do 60. That's kind of cool. Let's move it up a bit and then maybe make it thinner. So the y, let's do 1960.5. And then we'll do line width equals 0.2. Right. And maybe the end should be a little bit higher as well. Let's make it like 61.5. So that's cool. But we also want the arrowhead, right? And so we can then do arrow equals arrow. Okay, that's hideous. So that's like an open, right? So let's look at the help for arrow. And we want, yeah, so ggplot to arrow. Okay. So arrow. Okay. So angle 30, type open. So we want closed. So we'll do type equals closed. And then length is by default 1/4 of an inch. So let's do like 5 pt, and that needs to be within unit, right? Unit that. Where'd you go? All right. So that is kind of funky. So again, this is kind of where even my patients might get, might just be exhausted, right? Oh, that didn't work. Oh, I put this in the wrong place. Angle equals 20. And then let's make it 2 units long. That's not bad. Maybe make it 3 units. I think at the end, it's just kind of nosediving too quick. So let's maybe make this 40. Let's maybe take it back to 90. Yeah, I think that's pretty good. So again, I would encourage you to play with that a little bit. One thing that, hey, Stassism. Yes, thank you, Rents. I was just looking at this. That the legend, the 0, goes down to 0, right? Whereas all the other values are 2 decimal points to the right, right? So let's go ahead and let's tidy that up, okay? Because that's the kind of thing that I would finish this and look at it and be like, how could I leave that, right? So I'm going to go ahead and move this annotate back up to the top where I have all my other annotates. And let's see, get that there. Let's run it, make sure everything still works. Cool. Now what we want to do is to, now we want to do is to modify the scale fill gradient, right? And so I kind of showed you how I would do this earlier when we were thinking about that x-axis, right? Where we had 10 on the left side, but then I removed it. And so within scale fill gradient, we could do breaks equals, and let me just remind myself. So it goes from 0 to 0.25 by 0.05, 0 to 0.25 by 0.05, right? So this should not change anything, right? That's the same. But what we don't like is that 0.00, we'd rather it just be a 0, right? And so again, if we come to scale fill gradient, in here then the argument is labels, right? And so we could do 0, and then we could do seek 0.05 to 0.25 by 0.05, right? And so I think this actually needs to be in quotes, okay? So we got the 0, but the 0.1 and the 0.2 no longer have their trailing 0, right? So this is kind of a consistent problem, right? So like if you did seek 0 to 0.25 by 0.05, actually let me do 0.05. That's numeric, right? And if we pipe this to as.character, then it's actually trimming off the trailing 0, right? If I did format, and the input is going to be the x, and I do n small equals 2l, or 2, then that's going to put 2 values to the right of the decimal place, right? So this is what we're going to want to, that's what we're going to want here to make sure that our non-0 values have 2 decimals to the right of, or 2 values to the right of the decimal place, right? And it's going to annoy me that this is going off the right side of the screen. So there we go. There we go, right? Now we match the digits on our legend compared to their legend, right? Very cool. The question, I think the last thing I will try, so I will basically leave it to you to play with how to add these other types of lines, but that's the general idea. I don't know how really I would make this line except perhaps by splicing things together. There's a package called ggforce that might allow you to do things like this. But anyway, maybe what I will do is, because someone asked, I'm going to go ahead and copy this, the logo from the upper right corner, and I'm going to make a new thing, and I'm going to save this to my thing, to my directory, and I'll call it logo.png. Let's save it as a PNG. Save that. Okay. So the honest truth is I have no idea how to add this. So what would you do? I'm going to Google it, right? Add logo to ggplot2. How can I? Okay, here we go. So honestly, this, you're seeing how the sausage gets made, right? If I don't know how to do it, I'm Googling it a lot like everyone else, right? And so this is ggdraw, which is old, right? So it's using cowplot. So one thing I want to look for, though, is a date from something that's relatively recent, right? And so these are all a few years old. Add logo image. Let's see. So we can read the PNG and then annotate with the custom. Oh, I don't know. Maybe I'll copy what this guy's doing. So let's come back up here and I will read PNG or PNG, read PNG on logo.png. So I'll call this logo. And I actually wonder if there's another geom, like geom image, maybe. And if so, cowplot. Yeah. Let's see. All right, I'm not seeing it there. So I have the logo read in, and I wonder if plot annotation custom. I wonder if that's what I want to do. Let's try. Annotation custom logo. Let's do x equals, let's see. I'm going to put it kind of in the middle. 1930. What did he have before? X-min, X-max. Okay. So let's do 30, 35, 1930, 1935. Converting geom to grob. What does annotation? Annotate. All right. Let's take this back to annotation custom. And so I think he made a transformation up here with grid raster grob. I don't really know what it does, except perhaps it makes it play nicely with ggplot. So I'm going to go ahead and kind of modify his code to match my needs, right? So I'll get rid of this. Hey, no error messages. What do you know? But I don't see it. So it should be like right about there. Let's see. wonder if my reversing the axes is wrecking havoc again. Nope, I don't see it. Maybe I'll put it up at like in the upper right. So X max 55, 50, Y min 19, 15, 1910. I don't know. What is it doing? Let's see. One of the other suggestions, and I think Terrell mentions cowplot or ggimage. Let's try cowplot. So cowplot was made by Klaus O. Wilke. He has a really nice book on data visualization with R. He's a professor at the University of Texas in Austin, and he made this package to make it to kind of do stuff that his research group wanted to be able to do on their plots. And so I'm seeing right off the bat here kind of what I want. So draw image from cowplot. Okay, so let's go ahead and come up here and do library cowplot. I haven't installed it, so install. Is it not installed? Okay, let's try that again. Install cowplot. Okay, cool. Okay, so that's there. And so let's see, following his logo file, I don't think we need, so let's call this logo file. And my logo file is logo.png. We'll do that. And then we'll do draw image. And it looks like it's going to basically center it wherever I want it. So we'll come back down here and do logo or draw image. And so he's got a logo file, right? Logo underscore file. And we'll do x equals 50, y equals 19, 15. Magic is required to draw images. Image not drawn. So I need to install, let's just double check that nothing happened. Okay, so I need to install Magic. So Magic is an R package for working with a tool called ImageMagick, which is a really nice command line tool for working with image files. And so let's try that again. And I don't see it. All right. Let's go back to the demo. This might be like relative. So let's try x equals 1, y equals 1. Nope. All right. Well, I think because of time and because of start a plot at the top left and then work it through. Yeah, for some reason, or maybe I need to, let me copy all the rest of his arguments. Yeah, I'm not seeing it, unfortunately. So this is ggdraw. Oh. Okay, so I think we need to do something different here. So I'm going to call this P, and then we'll do ggdraw P, draw image. Oh, lots of warnings. But hey, We got our thing. What are all the warnings? It doesn't like my fonts. Well, it seems to like my fonts. So let's put, so X is at 1. Let's maybe make it 0.8, Y at 1.1. Puts it way up there. All right, 0.9. Let's change one variable at a time. Okay. Well, let's make this 1. Okay, that's good. So now we want to bring it down to 0 or 1. Okay, so like 1.05. Cool. And so the width and the height are probably too big. Let's maybe make it like 0.8 and 1.6. No, I don't think this should matter. Oh, that's too big. Okay. Let's see, the width at, oh, this is getting silly. All right, so that's about the same size. We can move it up a smidge. 0.06. Bang. Well, it's not happy about my fonts for some reason. I don't think it likes, for some reason I'm feeling like it doesn't like the annotate, or something weird is going on, right? So basically by adding the logo in the upper right, it caused some other problems with the fonts that I have in the rest of the plot, right? So I'm gonna stop here. We've been going a while here, but I really appreciate you all watching this and hope you enjoyed watching along. One of the things that I really hoped to drive home by doing this infographic is that you don't need to put things into Illustrator, right? Although perhaps this is the exception that proves the rule, but some of those arrows are just a little bit odd, right? And difficult to work with. And if I took some more time, I'm sure I could figure out how to do it with something like ggforce and that package. Of course, I am trying to recreate something that someone else made, and I don't know that I would necessarily make the arrows that they would have made in the first place. But anyway, my point is, I would strongly encourage you to make as much of the plot as you can in R. Why? Well, this data goes to 1970, the cohort born in 1970, right? Like, my wife is part of the 1977 cohort, right? And she's 48, right? And so she should be on this plot, or we might be interested in what this plot looks like, right? For people of her cohort. Well, it'd be much easier to recreate everything in R by going up to 1978 than basically making a basic plot and then going into Illustrator and doing all your Illustrator stuff, right? And so for reproducibility purposes, I think it's just really valuable to be able to make as much as you can in R rather than reflexively going to Illustrator or PowerPoint, right? And so hopefully what I've been able to show you is that you can do that type of thing, right? That things got kind of wonky here at the end, of course, and I might go back and clean things up, but I'm going to stop here. I really hope you enjoyed watching this along the way. I will be posting the code that I developed down below in the description for this live stream. I will try to be back next Wednesday around 9 a.m. Eastern time. Not sure. I think I have something else in the queue. I think I'm going to take this and try to make this into a heat map. I made a heat map a few months ago showing deaths by drug overdoses in Chicago by age and birth year. And so it's a bit of a different way of looking at the same data. And so I want to take that visualization from the New York Times and apply this data to generating that type of plot and to kind of see what's better, heat map or ridgeline plot. Okay, so thank you all very much, and we will talk to you soon. Please keep practicing with this. I'd encourage you to grab the code, practice with it, tell your friends what you're doing over here, and I'll see you next week for another episode of Code Club.